All right, welcome, everybody. It's that time of the month again where we sit down and talk about some cool Trino, or I guess in this case, kind of Trino related things. We're going to be specifically hanging out on thinking this whole data lakes topic, and specifically kind of this niche area that we've seen a couple times pop up in the Trino community, and we're starting to see a growing kind of demand for it generally. And so while this doesn't directly, sit like isn't a tool that directly sits on top of Trino or anything like that, it's one of these interesting query engines that are going to be like cooperating with Trino that basically enables exactly what it says here on the screen: graph queries on data lakes. So a lot of times, when you're trying to do these kind of entity relation mapping and trying to pull represent that data efficiently and pull it out, there are ways you can kind of hack this a little bit in Trino in SQL, but there's like largely a lot of lacking syntax for doing this type of thing. So a lot of newer kind of querying languages like GraphQL have come out in let's say the past decade or so. I probably many more before that, but GraphQL has risen into popularity at least in the last decade, and has become kind of the way that you can query, and it has a lot of good syntax support for pulling out kind of answers from graph represented data, and you don't have to do a lot of this extra work that you would traditionally have to do with SQL, and some that just is flat out pretty much impossible to get done in a SQL thing. And when it comes down to it, like nobody wants to have these giant SQL statements to just do graph queries inside of a SQL query. It doesn't look very well. So basically, we're going to be having our guest today, Weimo Liu, who's going to be talking to today about how to run graph queries on data lakes. And this would be essentially kind of a nice extra component that sits alongside Trino, all working on the similar kind of table formats like Iceberg, and open source formats like Parquet and Orc and these kinds of things. So still the same kind of underlying representations, but yet both query engines can work on the same thing. Think about this as kind of another variation of like when we have an engine, say like Apache Flink or something like that. It's another query engine that's doing a certain type of processing, but it's a specialized type of thing. For those that are new to Trino, I just wanted to give a quick little spiel about what Trino is. So Trino is a distributed SQL query engine. The query engine differentiates it from a traditional database in the fact that it doesn't have its own storage. In some cases, like in the data lake case, it's using object storage or file storage of some sort, like HDFS, or and then it'll have some sort of like metadata layer that's doing that. So these are connectors like Hive, Delta Lake, Iceberg, and Hootie. And so you have these types of connectors, and then you also have other types where you're connecting to Trino to like SQL databases. And why would you want to have a SQL query engine on top of a SQL database? Well, you can actually then, let's say you have a Postgres database and maybe two Postgres instances. Trino would actually enable you to merge data between those two instances, or merge data from Postgres to your data lake, to any other source that or destination that Trino can connect to, and that all can be like all those transformation, all that moving around, and all that stuff can be represented in SQL. So that's what Trino is really trying to do, and so my company Starburst builds on top of Trino. And essentially, we take some of the pain out of really deploying and getting Trino up and running, a lot of the maintenance nightmares out of there. So that's just a bit of a skinny of kind of what Trino is and what my company does on top of that. And so again, getting back to the kind of subject of graph queries on data lakes. We don't specifically cater to graph queries. You can, as I kind of mentioned before, like do a lot of this graph query stuff through SQL, but it is a mess. And so it is much better to have like direct syntax support for this type of operation. So before I introduce Weimo, I'm going to do a quick talk about how to, get involved with the Trino community if it's something of interest to you, and basically other ways that you can kind of start to learn how to contribute. So first and foremost, the best way to kind of get to know people and be a part of the Trino community is to join our Trino Slack channel. It's trino.io/Slack. And by the way, we're about Anna, if you could send through that URL. There's basically, we have a page that has all of these links on them so that you can just click on that link. So in a second here, we'll share that with you and then post that up here on the screen. So don't feel like you have to frantically write all of these links down. So outside of the Trino Slack, Trino Slack works really well for a lot of things. Thank you, Anna. So Trino Slack works for a lot of things. So basically, you can use it for as a user of Trino that wants to learn, how do I do XYZ thing on Trino, or I'm just set this up and I'm getting this error. How do I fix that? You can also join on there so that you'll usually go to like hashtag troubleshooting, or I say hashtag, I should probably say like channel, the troubleshooting channel, or and there's also a beginner channel if you're like not sure if this is like total noob territory and you're afraid to ask a question. We have a beginner channel like specifically for newcomers to the project, and so you don't feel intimidated to ask literally anything there. So those two are good for like users. And then if you are a developer, you want to start, you code in maybe Java or Python or one of the other variants of projects that we have in different languages and stuff, or Kubernetes super well, or Helm, or this kind of thing, you can get involved in the developer side, and Trino Slack is yet another area where we kind of collaborate on the developing side. So that's definitely a great resource, like top resource. If you're going to take away one thing from this slide, go to the Trino Slack and sign up for that. If you want to contribute to the project, over here on the right, that's trino.io/development. That is going to kind of give you the process for how, to become somebody who does contribute code or documentation, or really anything from the contribution side that requires kind of an interaction with like Git or our versioning systems. That's the place to go. If you want to just learn more, like have more stuff, like kind of meetup style stuff, but it gets a little more in the weeds, there's a Trino community broadcast where my friends Cole and Manfred join me, and we basically just talk about what's going on in the Trino community, what are the latest releases that happened, and stuff that's coming on down the road that you can get excited about. So definitely go and check that out. We try to make it fun. I think we succeed, but you can make your own opinions there. Next one, write blogs or docs. Trino.io/blog is where our blog is located. And so if you want to write a blog, actually, the way that you do that is reach out to on Slack and say, hey, I want to write a blog. You can reach out directly to me, or you can just reach out on the beginner or developer channels, right? And just say, hey, I have a cool blog and thing I want to talk about, and we'll beat you there. Another thing that you can do is go to under the TrinoDB Trino repository. You can go under the docs subdirectory, and when you go in there, there's going to be a whole README about how to contribute docs, which is a little easier to do than if you don't know Java code, but oh, hey, there's this thing in the documentation that tripped me up or was a little confusingly worded or something. It's a lot easier. I think there's a lot more of these kind of easier to get into the development flow before you jump right into some sort of piece of code. And it's a good way to get to familiar with the project. Right now, here to the left, Trino Virtual Meetups. We are in the Trino Americas group right now that you're tuning into, whether it be on YouTube or any of the other platforms. But the way to keep up with all of these is to join one of these meetup groups. We are in the process, and I've been saying this for like a little over a year now, but we really are in the process of making things happen in EMEA and APAC. There has just been various setbacks that we've had here and there, but as things are starting to become more in person, open up, and this kind of thing, we are basically getting to a point where we will be doing more hybrid type meetups, not just in the Americas, but also in EMEA and eventually in APAC. So, if you're in those areas and you want to tune into these, definitely tune in and find those out. And then also, lastly, we have a Trino forum. It's at trinoforum.org. And this is and again, all of these are in that this Trino community resources link. So if you don't want to remember all these, just go to this one. It's in the YouTube chat, and you'll be able to find it there. So basically, just go to trinoforum.org, and it is kind of a way that we're taking knowledge from that's being discussed in Slack, but essentially Slack is a little more ephemeral. Things kind of dissipate and go away. We're trying to curate some of those conversations and put them into the Trino forum so it's searchable by Google and this kind of thing. So that was a mouthful. There's a lot of stuff going on in terms of ways that you can engage with our community, but I always want to make sure that we cover that. At the very basic, if you're wanting to just remember where we are on GitHub and you want to give us a little bit of notoriety and visibility to the rest of the GitHub community, please give us a star on GitHub at TrinoDB/Trino. I use it to kind of bookmark stuff, but also it gives a lot more visibility as more stars show up. So without further ado, I want to introduce Weimo. Let me pull him up right here. Hey, Weimo, how are you doing?
Hi, good. How are you?
Doing well. So I'm really excited to hear about this kind of some of these kind of difficulties that I kind of mentioned, where when you're trying to do these kind of GraphQL queries and trying to, or it's not just GraphQL, but graph queries in general. You can do it in SQL, but it's not easy, is it? Right? It ends up requiring a lot of extra specialized coding and kind of functional procedures, and usually stuff that if something does support it, it's outside of the ANSI standard, which Trino very closely follows the standard. Maybe someday, there will be some meshing of SQL and graph capabilities, but at least for now, we're kind of stuck with, we have to do SQL or GraphQL. And so you have a system that specially supports this type of workflow. So could you talk about PuppyGraph and everything that's kind of how PuppyGraph works on top of a data lake?
Yeah, thank you so much, Brian. Yeah, I really appreciate this opportunity, since I think Trino is the most important player in the SQL world, and we very appreciate that we can collaborate with you guys.
We totally appreciate you joining us as well, and for all those users that have been scratching their heads figuring out how to do SQL queries on their data lake, please enlighten us.
Yeah, and our target is that we can be the Trino of graph in the future. Yeah, I hope that we can make it. Yeah. We usually use different data models to handle different use cases. And for example, relational table database is the most popular, and we already do a lot of data analysis, like Trino. And also there are some others like key value and graph. And I think based on the use case, if the data nature is to be a graph, I think maybe we can think in a graph model and query as a graph model. And some example is that cybersecurity, fraud detection, and social network, and so on. And for fraud detection, we usually have a complex schema, and also we need to traverse a lot of hops through the entire graph. And for cybersecurity is as well, we have a lot of data traverse from different nodes. And also customer 16C0. So the schema is complex, and we have some multi-hop query on the graph. And the graph actually increased a lot, but still compared to SQL, it's a kind of a niche market. And actually, we think about the reason, since it's hard to use a graph database, since if someone only have one choice, SQL database must be their choice. But a lot of users want to use graph analysis. So since a lot of big player like Starburst promoting data lake, I think we can take advantage of it. And the user don't need to do some data migration. They can just directly query the same copy of data. If user want to run SQL query, they can use Trino. If the user want to run graph query, they can use PuppyGraph. And then the different tools can be seamless collaborate together to make up a super big data pipeline. For example, maybe there are 10 steps, and several steps are SQL, and several steps are graph, and several steps are machine learning tools, and your output can be our input, and our output can be your input. And since for the SQL world, actually different use cases are already occupied by different players. For example, if we want to do some data analysis, maybe Snowflake as a data warehouse, maybe Iceberg with Trino as a lakehouse, and for the abstract use case, user use MySQL or CockroachDB to do some transactional operation. For the graph world is kind of weird, since most of our product claim they are a graph database, but based on our observation, a lot of users want to do graph analysis. So we are focusing on it, and we claim us as a graph data lakehouse. Of course, lakehouse have a lot of advantage, and I think you guys already know a lot about it, like low cost, less ETL, and storage of any data type, and infrastructure abstraction, and limitless scalability. And based on that, our product can have this advantage compared to others, like first, fast and scalable. Since data lake itself is very scalable, basically there is no limitation for the data size. And we take advantage of this, and our query engine is also distributed and multi-thread processing. So it's fast and scalable. It can answer some complex query like 10 hop neighbors. And we also support different data source by leveraging the technique of data lake, like Iceberg, Hoodie, and Delta Lake. And we also support different query language like Apache Gremlin and Cypher. And we support the open lakehouse architecture, and then we can integrate with some other system like Trino. When user want to they already have a lakehouse structure like Trino on Iceberg, and then we can be integrated with them. We don't need to maintain another copy of data. And this is how we implement it. And we are just connected the Gremlin client and to the Gremlin server. These are all based on the open source standard, and we are one of the implementation of it. And we also our roadmap, we are also developing the Cypher, which is supported by Neo4j as well. Yeah, and our query engine will, based on the query incoming, we will have generated some plan, and based on different storage, we will have a different execution plan. And we have our own storage if the user want to have the best performance they can have. But we can also support Iceberg, Delta Lake, and Hoodie. And the data can be in different storage format. And also, it's not our storage is kind of an option. User can take a look at which kind of data is more popular in their entire data lake, and just materialize view that small set of data into our system to get a balance from the performance and less data migration. So our product compared to some other graph products, the advantage is that we are lakehouse architecture, cloud native, since obviously data lake architecture is cloud native, and we can have a good performance and scalability, and we don't need to maintain the data replication by ourselves. Based on our engagement with the current graph users, and usually they will ETL the data from data lake or data warehouse to a graph database, and then run graph query. I think in this case it doesn't make sense, since you never ETL a data from other place to a database. And so actually we don't take advantage of the database. We do graph analysis with a database is something like run analysis SQL query on MySQL, which is not efficient and high cost. And with PuppyGraph, the structure is more easy, since all the data are in data lake. And the user can use Trino to run SQL query and can use PuppyGraph to run the graph query. And we borrow this picture from Databricks. They claim that data lakehouse is a more advanced architecture than the data warehouse. Of course, the user can still use it as a data warehouse. Then user need to ETL the data into our system and then run graph query. But the user can also use us just like a SQL query, graph query engine. It's on a top layer of data lake. The user can directly query the data from the data lake and write it back into data lake. Then, for example, use a graph query engine to extract the features of a graph, and then the data, which is the result of us, can be used by machine learning tools to do the training. We also show in some other way, like the solution without PuppyGraph is that all the data ETL to or streaming to data warehouse, streaming to data lake, and then ETL to graph database, and then user use SQL to access the data warehouse and the data lake, and the graph user run graph query on top of graph database or some other graph product. But with us, it will be pretty simple. All the data will be going to data lake, and the user can run SQL query by Trino, and the user can run graph query by PuppyGraph. And we already published our beta version or alpha version on AWS Marketplace. And currently, we can use it as a data warehouse, and the single node can be manually create a cluster, and also it can be connected to your existing Iceberg. In this case, you don't need to ETL the data. You just connect the Iceberg and have a mapping. Then you can just run the query. For example, here's an example to create a data lake. For example, data in HDFS, and the Iceberg catalog is available in high metadata store as here. And then we can insert some sample data into the data lake. And then we can just need a JSON file to have the schema of the graph, and then user can directly query the data on it. First field of the JSON file is the catalogs, which is the IP address of the Hive meta store URL, and we given the type is the Iceberg. And then in the same JSON file, another field that is the vertices. And for example, if we have a type of vertices like a person, and then we map this type of vertex to the table of person in Iceberg. And also we have a mapping from person's ID to the person ID in Iceberg. And then all the attribute name and type, we just need to look at the Iceberg and what we have and just type it here. It can be a subset of the data Iceberg, since maybe vertex has more than 100 attributes, but if you only want to access some of them, you don't need to list all of them. You only need to list some of them. And for edges, it's similar to vertex, but the difference is that we need to point out which column is source from and which column is to, and then you will have a table address mapping to the tables in Iceberg. And that's all. And you can directly write Apache Gremlin query now to query the data set in Iceberg. And the Iceberg data is still in the table format, and you don't need to do any change. And this is our performance benchmark. Comparing with Neo4j on Twitter data, the red one is our running time of each query. We run a 3-cop query from a different source, a different vertex as a source. And the red one is our performance runtime, and the blue one is the running time of Neo4j. And we also compare with TigerGraph. TigerGraph claim that they are the fastest one, and is the only one can run 10-hop query. And so we compare with them on 10-hop query, and we can see that the orange one is our performance on the runtime of the query, and the blue one is the TigerGraph. And this is based on the local story. If you want to do any ETL and don't want to do any materialized view, you will be 3 or 4 times slower if you access Iceberg. But based on my observation, Iceberg is more and more fast. So maybe we don't need our storage in the near future. And thank you. I think that's basically what we have today. And the glue, the glue is under development, and we will release support soon. And for OpenCipher, which is designed by Neo4j, is also under development. We already test the basic function. And if you just want to use Apache Gremlin, you can directly run the query or just copy your existing use case to our system, and you don't need to, we use the same client, so you just need to change the server IP address to us, and then you can run your existing use case. And I think for Iceberg, we haven't tested all the different versions. So if you don't have something not smooth, please contact us. We will answer the question and help you to have a smooth experience immediately. And your feedback is very important for us, and we definitely will help you to solve the problem as soon as possible. Yeah.
All right. Hi. Thank you so much. We have a couple questions. So traditionally, graph databases have their own representation for graphs. How well do edges and nodes map to columnar formats like Parquet and Orc? And what are the performance implications?
Yeah, I think Parquet is already a good data format, not only for the SQL tables, but also good for the graph analysis. Yeah, maybe it's not as fast as our native one, but I think it can already satisfying most people's requirement, since based on our observation is maybe at least 10 times faster than Neo4j. Yeah, but I want to say 100, but yeah, I think it's too confident. So
awesome, thank you. And then last question is PuppyGraph open source, or will it be?
It will be, but since we have some secret in our design, and currently we have a technical bar and a big advantage compared to our potential competitors. So maybe we get some names. We have some names, and when user know us, we will be open sourced. Yeah.
Got it. Awesome. I don't think we have any additional questions in the chat. But thank you so much for joining, and thank you all for attending. This will be posted on the Trino YouTube and the Starburst YouTube for future reference.
Yeah.
Yeah.
Thank you so much. Yeah, kind of nervous today. It's our first time.
Great.
Yeah.
Thank you.
Thank you.